Sir Isaac Newton was a physicist, mathematician, and astronomer. He has been considered to be the greatest and most influential scientist who ever lived. In 1687, he lays the foundations for the most classical mechanics.
In his works, he describes the universal gravitation and the three laws of motion. In his theory of gravitation, it advanced the scientific revolution.
Newton's first law states that an object at rest will stay at rest, and an object in motion will stay in motion until another outside force acts upon it. As you see, Peyton and Sarah are going to drive by in a car, and they're going to throw a potato. When they throw the potato will go straight, and the car will keep moving. As you just observed, when Sarah threw the potato out, there was no other acting forces acting on it, so it just went straight when she threw it, and the car kept going that way. This is the second example of Newton's first law. An object is not going to stop unless it has another outside force acting on it. Sarah is going to run, but she might have some falters. As you can see, Sarah was running, but the garage, being the outside force, caused her to stop.
Okay, as you saw me, I ran into the garage because I was running with like a constant speed, but an outside force was acting upon it, and so it stopped me. And Sydney's going to do the same thing. He goes into a mailbox. Okay, since it was an outside force and Sydney was running, she ran into it, and since it was at rest, it stopped her.
This is another example of Newton's first law.
Okay, she was running and an outside force was acting upon it, and I pushed her, and so she fell to the ground and she stopped. This is Newton's second law, and it says the acceleration produced by a net force on an object is directly proportional to the magnitude of the net force. It is in the same direction as the net force and is inversely proportional to the mass of the object. So we have a toy car and a real car, and we're going to push them both, and since the toy car has less mass, it's going to go further than the real car. Okay, you ready?
Yeah.
Okay, 1, 2, 3. As you can see, the toy car went way farther than the real car. Peyton's neighbor is using the second law. When he is riding his bicycle, he is accelerating because the dog is moving him.
The dog has a push or pull from the bicycle, and we have to talk quiet. So the dog stops, and the neighbor
has to stop.
He pulls him. See how the dog pulled the neighbor. 1 second. This is gonna be good. Get close. So as you can see, the dog is trying to use the bathroom, but the neighbor is pulling on him. Therefore, the dog is reacting, and the dog is moving with the neighbor like so. And now he's staring at us like we're...
Whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. In this demonstration, we're showing that the bird is flapping its wings down, so it's pushing air down, while the air is pushing them up.
As you can see, this demonstrates Newton's third law of motion. When I hit the ball with my hand and it goes on the ground, there is the action of the ball hitting the ground and the reaction of the ground hitting the ball. There's a force from the ball on the ground and a force from the ground on the ball. Just like Newton's third law says, for every action, there is an equal and opposite reaction.